Hello, Algebra 1. We are so close to being done with Chapter 6, and it feels so good, doesn't it? Today we're going to work on 6.8, which is all about multiplying polynomials. We are going to learn a method called the FOIL method, and the word FOIL is just a mnemonic device to remember the words first, outer, inner, last. So first means that you want to multiply the first term from each set of parentheses. In this case, it would be a 3x times x. That would be the first term in the first set of parentheses, and x is the first term in the second set of parentheses. So as you see right here, we're going to multiply those together. Then we go to the O, which stands for outer. That means the outermost terms, so the far left and the far right. So we're going to multiply this 3x times this negative 5. Notice that minus sign is attached to the 5. The sign goes with whatever is directly behind it. So we're going to multiply the 3x and the negative 5 for outer. Then the I stands for inner. Well, if we've already said that the 3x and the negative 5 are the outermost terms, then the positive 4 and the positive x are the innermost terms. So we're going to multiply those together. And then L stands for last, which just means we want the last term from each set of parentheses. So the 4 is the last term from the first set of parentheses, and the negative 5 is the last term from the second set of parentheses. So we're going to multiply those together. So now let's get to the multiplication. 3x times x, remember when you're multiplying and they have the same base, you add the exponents. So they each have a base of x, and they each have an exponent of 1, and 1 plus 1 is 2. So that's where 3x squared comes from. Then for our outer term, 3x times negative 5 is negative 15x. For the inner term, we had 4 times x, which is just 4x. And for the last term, we have 4 times negative 5, which is negative 20. Out of those 4 terms, it just so happens that those two in the middle are like terms. Remember, to be alike, they have to have the same variable as well as the same exponent, which they both have an x to the first power. So negative 15x and positive 4x turn into negative 11x. So that our final answer, written in descending order, is 3x squared minus 11x minus 20. So one thing I'd like to point out, and it says it right over here, that the FOIL method is going to be used when you are multiplying a binomial times a binomial. Remember, binomial means that you have 2 terms. Notice that this set of parentheses has 2 terms. This second set of parentheses also has 2 terms. If you get a trinomial or something that's any other size, you cannot use the FOIL method, and we will see that today, and we will talk about what we do if that happens. But for right now, we're just going to work on using the FOIL method. So example number 1, we're going to use the FOIL method. We're going to start with the F, which stands for first. So we're going to multiply the first term of each set of parentheses. So I'm going to multiply the 4x times the 2x. That takes care of the F. Then we're going to move to O for outer, outermost terms. So the 4x is on the far left. The negative 3 is on the far right. So those are going to be the 2 terms that I multiply together for the O. Then I'm going to go to the next letter, I for inner. That's going to be these 2 right inside here. So I have a positive 1 and a positive 2x. And then I'm going to get to L for last. I want the last term from each set of parentheses. So that positive 1 and the negative 3. Now I'm going to do the multiplication. So for first, 4x times 2x is 8x squared. For outer, 4x times negative 3 is negative 12x. For inner, 1 times 2x is 2x. And for last, 1 times negative 3 is negative 3. Now I want to combine like terms. These 2 in the middle, negative 12x and positive 2x, those are alike. So I'm going to keep the 8x squared in the front. The 2 in the middle turn into a negative 10x. And at the end, I'm going to keep the minus 3. And so there's my answer written in standard form. All right, number 2, we're going to do the same thing. I'm going to start off with first. So I'm going to do the first term from each set of parentheses, so x times 6x. Then I'm going to work on outer. So on the far left, I have x. On the far right, I have a -7. Then I'm going to work on inner. So inside, I have a -5 and a positive 6x. And then L for last, I have a -5 times a -7. So now let's multiply. X times 6x is 6x squared. X times -7 is -7x. -5 times 6x is -30x. And -5 times -7 is a positive 35. So looking at my terms, 6x squared, there's nothing like it. -7x and a -30x combine to give us a -37x. And then the positive 35 at the end is also alone, nothing like it, and so that would be our final answer. All right, example 3, same thing, first, outer, inner, last. So first, I'm going to start with 8x and 2x. Outer, I'm going to go with the 8x and the 1. Inner, I have a -3 and a 2x. And then last, I have -3 and positive 1. 8x times 2x is 16x squared. 8x times 1 is 8x. -3 times 2x is -6x. And -3 times 1 is -3. So I'm going to have 16x squared. The 2 in the middle, 8x and -6x, turn into a positive 2x. And then I keep my -3 at the end. All right, example 4, we're going to do the same thing. First, I'm going to have 3x times 4x. Outer, I've got 3x times 7. Inner, I have 11 times 4x. And last, I have 11 times 7. So 3x times 4x is 12x squared. 3x times 7 is 21x. 11 times 4x is 44x. And 11 times 7 is 77. So now combining like terms, I get 12x squared plus 65x plus 77 as our final answer for number 4. All right, so real quick, let's review the distributive property. So if we look at example 5, if we were to take the x and distribute it to the trinomial that's inside of the parentheses, I would have x times 3x squared. Let me write this out. X times 3x squared plus x times 6x minus x times 8. I'm just taking that outside x, distributing it to everything inside of the parentheses. X times 3x squared turns into 3x cubed. Remember, keep the base, but you add the exponents. So this one had an exponent of 1, this one had an exponent of 2, that's why I have an exponent of 3, plus x times 6x. Again, same idea. Keep the base, add the exponents. So we get plus 6x squared, and then at the end we have minus 8x. None of those are like terms, so we're done. Let's try the next one. Same idea, just doing the distributive property. Negative 3x times 2x squared. Let's start with the coefficients. Negative 3 times 2 is negative 6. Then we have the same base of x. So we're going to add our exponents. We're going to end up with an x cubed. Now we're going to take negative 3x and multiply it times negative x. Let's start with our coefficients. Negative 3 times an understood negative 1 turns into a positive 3. And then x times x is x squared. Lastly, negative 3x times positive 4 is negative 12x. So that's a good refresher of the distributive property. You might be wondering, why are we doing that? Well, wanted to show you that you can also use the distributive property instead of using FOIL, and some people like this better. So here's the way that this works. So here's a problem. We're multiplying this binomial times this binomial, kind of color coordinated it here to show you that I'm going to take this first binomial and I'm going to break it up. I have an x and the positive 2. And what I'm going to do to both of those terms is I'm going to distribute them both to that second set that's in the parentheses. So the x is going to get distributed to the x minus 3, and the positive 2 is going to get distributed to the x minus 3. So when we do that, we end up with an x squared minus 3x plus 2x minus 6. Again, I would combine the like terms and end up with x squared minus x minus 6. So just showing you that if FOIL is not something that you would like to do and you want to just stick with the distributive property, you can do that. So I'd like for us to do that with example 7. Even if you do feel comfortable with FOIL, I want us to go over how would this look if we had to use the distributive property. So we're going to take this first term, or first set of parentheses, and I'm going to break it up. X minus 2. We're going to take the second set of parentheses where we had an x plus 4, and we're going to put it behind each of those terms because we're going to distribute the x and the negative 2. So here we go. X times x is x squared. X times 4 is 4x. So I've distributed the x to the one set of parentheses. Now I'm going to distribute the negative 2. Negative 2 times x is negative 2x, and negative 2 times 4 is negative 8. Now I'm going to look to combine like terms right here, 4x and negative 2x. That tells me the x squared is not changing, but 4x minus 2x is a positive 2x, and then I still have the minus 8 at the end. So had I done this with FOIL, I would have gotten the same answer. Let's try another one also using the distributive property. So here we go, example 8. Again, I'm going to take that first set of parentheses and I'm going to break it up because I'm going to distribute each of those terms to the second set of parentheses. So let's distribute together. 2x times x is 2x squared. 2x times 2 is 4x. Now I'm distributing a positive 1. Positive 1 times x is a positive x. Positive 1 times 2 is a positive 2. Now I want to combine like terms. There's nothing like 2x squared. However, in the middle, 4x and 1x can add to become 5x, and then we still have the plus 2 at the end. Now you might be wondering, why did I want you to learn the distributive property as well as FOIL? FOIL works only if you have a binomial times a binomial. But in some cases, we might do a binomial times a trinomial, or we might do a trinomial times another trinomial, and in which case you cannot use FOIL any longer. You would have to use the distributive property. So that's why I wanted us to practice, because in these next two examples, that's what we're going to be doing. So if you look at number 9, I've already actually started it for us. Again, I took the first set of parentheses, the x plus 4, and I've split it up. Then I took the second set of parentheses and put it behind each of those terms because now we're going to distribute together. So x times x squared is x cubed. X times negative 5x is negative 5x squared. And x times 7 is 7x. So far we've distributed the x. Now we're going to distribute this positive 4. So positive 4 times x squared is positive 4x squared. Positive 4 times negative 5x is negative 20x. And positive 4 times 7 is positive 28. And now that we have it fully distributed, we're going to combine like terms. I've got an x cubed in the front that's not going to change because there's nothing like it. Then I have a negative 5x squared and a positive 4x squared, which when I add those together, I get a negative 1x squared. Then we have a positive 7x and a negative 20x. 7 minus 20 would give us a negative 13x. And then lastly, we have a positive or plus 28, which goes at the end. So let's try this last example together. I'm going to start by taking the x minus 3 and I'm going to break it up because I'm going to distribute each one of those to the 3x squared plus x minus 4. Again, we were unable to use FOIL for this one because we have a binomial times a trinomial and FOIL no longer works. So let's distribute together. X times 3x squared is 3x cubed. X times x is x squared. And x times negative 4 is negative 4x. Now we're going to distribute a negative 3. So negative 3 times 3x squared is negative 9x squared. Negative 3 times x is negative 3x. And negative 3 times negative 4 is negative 12. And now comes the easy part. We want to look for like terms. 3x cubed, there's nothing like it, so it's going to go in the front. We have a positive x squared and a negative 9x squared, and that combines to give us a negative 8x squared. Then we have a negative 4x and a negative 3x, and that's going to combine to give us a negative 7x. And then lastly, we have minus 12, and now we have it written in descending order. All right, so I believe your homework is in the book. If you guys are having any problems, send me an email and I will answer as quickly as I can, and I will see you in the next video.